It's a volcano turtle. Oh god, Campbell didn't prepare me for this shit. Okay. The Elder Dragons in Monster Hunter have always been really fun, because while the games keep at least some of their monsters grounded by basing them off of real animals, the Elder Dragons let the designers go nuts with the justification that these are incredibly rare quasi-mystical creatures. So you get things like Exploding Lion, Metal Dragon, Zombie Dragon, My First OC Dragon, and Exploding Lion 2. Now the fire is blue.
Don't flatter yourself. You were never even a player.
Trying to explain these creatures based on our world's biological laws is an exercise in futility. But it's the only exercise I'm getting this week, so why not? Zorah Magderos is at least loosely based on a turtle or tortoise. As with a lot of fantasy creatures that take their design from the Order Testudines, the features between the families are mixed. For example, Zorah Magderos is at least functionally amphibious, which would point towards turtle, but it doesn't have front flippers. Still, I'll be using turtle because it's fun to say. Zora's head is reminiscent of a snapping turtle, with a large, very specifically shaped beak and not much else, which is fairly standard for a turtle. They slice into their food with the beak and then swallow it whole. It would need tons upon tons of food every day just to survive. There's no way it would be able to handle that in our world, but Monster Hunter is a world full of fantastical creatures, and it likely eats whatever it finds on or near the ocean beds. Giant crabs like the Hermitor would fit the bill if there were enough, or plants the size of buildings. But really, you're not here for that. There are two main features of Zora that we need to explain. He's big, and he has lava coming out of his back. Allometry is the study of the size and shape of organisms. There's a lot of different parts to allometry, but we're going to focus on two main ones. First, a large animal needs a lot more surface to perform gas exchange to provide its huge mass with oxygen. Second, the support structures of the animal need to become thicker to support its vast weight. That's why elephant legs look like this. Zorah Magderos has some weird allometry. It's so large that it would have to be made almost entirely of lung, and there are no bones in the world that can support something so heavy. Zora's arms should drop off as the bones, muscles and tendons are ripped apart by their own weight, and that's without adding the mountain on top. But somehow this thing stays together. Hell, it even moves. Astounding. So we have to assume that whatever Zora is made of, it's not flesh and bone as we know them. Standard bone is made of mainly hydroxyapatite crystals bound together with collagen, so we need something stronger than that. The first thing I thought of was the aquatic snails that used iron in their shells, but the compressive strength of iron is less impressive than I'd hoped. But iron is only a bit of carbon away from being steel, and carbon is something most creatures have in abundance. So, best guess right now is steel holding Zora together. But how much needs to be held up? Well, we can't see all of Zora because of his rock plating and all the water in the way, but he looks surprisingly skinny when on his hind legs. The databook gives us a length of 257.64 meters. If we assume Zora to be a quarter as wide as he is tall, then we can model him as a cylinder with a volume of 3.35 million cubic meters. Then, if we multiply that by the mass of water, we reach 3.3 billion kilograms. This is imperfect, but it's close enough. Living creatures are always made mostly of water, and although I suspect Zora to be even heavier, there's no better solution at the moment. Besides, now we need to calculate the mountain. I would love to calculate it as a cone shape, but Zora has too much on his arms for me to be comfortable with that. This is going to be an even rougher estimate, but I'm going to assume that it's a solid basalt cylinder about half the size of Zora himself. Basalt makes the most sense considering the colour of the rock. This gives us a further 2.5 billion kilograms to add. So add all that in, apply the strength of steel, and each leg would have to be 50 meters in diameter. which it is certainly not. Okay, what's stronger than steel? In the real world, we make our huge structures out of steel-reinforced concrete, which is strong but also crumbly. It gets damaged by high heat, like say, a lava turtle, and it has low tensile strength, so it would crack and break apart when Zora lifted his legs. Tungsten? Let's look at tungsten. Strong, heat-resistant, and with good tensile and compressive strength, but low impact strength. It would shatter too easily under Zora's enormous, ponderous steps. So, Tungsten Carbide? The metal with the highest compressive strength of any we currently know about. With tungsten and cobalt being common in volcanic rock, and carbon being readily available everywhere, I must assume that Zorah Magderos gathers these metals from the basalt, either on its back or in its lair, eats them, and then dives down into the mantle to reach the temperatures needed to smelt the tungsten carbide it needs to keep itself from collapsing into a pile of mush. It would be unlikely for the tungsten carbide to be the only thing making up its bones. Likely it would be mixed with iron and other metals and held together by some super strong collagen matrix. Presumably the same stuff is threaded throughout the rest of its body, holding it all together. Honestly, it's a bit unsatisfying to have to conclude that Zorah Magderos can biologically create one of the strongest materials in the world just to keep itself upright, but I don't see any other possibility. Also, it probably solves the lung problem by breathing through its butt, like other turtles, as well as what I assume is blood with a super high blood cell count, slower heartbeat, and muscular oxygen stores. Incidentally, the fact that it spends most of its time hunched over probably takes a lot of stress off its heart, which is another problem for super large creatures. Zora's huge size also means huge temperatures. Organisms are always pumping out a certain amount of heat due to cellular activities. So I took the mass calculation from earlier, applied Kleiber's law to get the joules of heat Zora is producing, and then applied the average specific heat capacity of basalt to find that if Zora dedicated its entire daily energy to melting rock, it would be able to melt about 75,000 kilograms. Which isn't bad, but you'll note that that's less than 0.003% of the mass that it's carrying on its back. So we've reached a point that I'm actually super surprised by. Zora is cold-blooded. Don't get me wrong, its body is several hundred degrees, but it has to take that from elsewhere, specifically the lava on its back. Zora's magma cores don't generate heat, they leach it from the surrounding lava to feed it into the main body. They would have to have large blood supplies and surface areas to leach as much heat as possible. When they're destroyed, they go dark, indicating that the heat flow has been interrupted. This is why Zora weakens whenever you destroy a core. It's starting to lose heat, and its muscles are slowing down. If Zora is reliant on the mountain for survival, it makes sense that he needs to refresh it from time to time. Though since lava takes so long to cool, and since there's so much of it, he probably doesn't have to do it too often. But all he'd have to do to refresh it is jump in a lava pool or break through surface rock to reach deeper magma chambers, something that's surprisingly common in the Monster Hunter world, and something we've seen him do at least once. Water absorbs heat better than air, and so the swim to the new world would have probably been fatal, but I would put money on Zora not swimming, at least not in the ocean. Instead, he dove deep and broke his way through a volcanically active spot, and then rode the magma until he needed to surface again. So, heat. Heat is a huge problem for living things, because the molecules they're made up of stop working as the heat increases. Take enzyme activity. Enzymes are super important, allowing the body to make stuff, destroy stuff, recycle stuff, etc. Every cell in your body has thousands of enzyme reactions occurring at any time. For humans, these enzymes sit at a comfortable 37 degrees Celsius, and if you vary that, the enzyme starts to lose function. If the temperature drops too low, the enzyme and the thing it wants to act on lose energy and are less likely to connect. At high temperatures, like for example, the temperature of a lava turtle, enzymes denature, twisting, breaking apart, and generally becoming useless. This is just in humans though. Let me introduce you to the Extremophile, a type of creature that thrives in environments that severely hamper ordinary organisms. Zorah Magderos is pretty obviously a thermophile, a creature that thrives in heat. This takes a lot of adaptation. First, it's got to have hyper-advanced DNA repair systems. DNA breaks down at high temperatures, so repair has to be constant. Its RNA should have as many GC pairings as possible since they're more thermostable. Then it needs to protect its enzymes, which other thermophiles do with special enzyme folding. But honestly, all of this is based on Earth thermophiles, and they're just not good examples for this sort of thing. First of all, hyperthermophiles are all single-celled, which is why you can't see anything in this footage of hot springs, even though they're filled to the brim with thermophiles. There's none of the intracellular machinery that a complex organism needs to function, which means they don't have to adapt any of that to high temperatures. Secondly, the most hyper of the hyperthermophiles is probably strain 121, which lives comfortably at, you guessed it, 121 degrees Celsius. Lava is 700 degrees Celsius minimum. It goes up to about 1250. There's simply no comparison here. It's like trying to explain the mechanics of an aeroplane by researching a balsa wood glider. So let's assume, for the sake of my sanity, that Zorah Magderos just works. Its cellular machinery is all perfectly adapted to the temperature it lives at. It does not cook itself. With all this established, it makes Zorah Magderos really interesting. It carries not just its home, but functionally its environment on its back. It's almost human, functionally no different than a submarine, a tiny pocket of a survivable environment that we take into the most hostile places in the world. The Monster Hunter world.